We're going to start at example 5. That was the last example we did in class, or previous example, example 4 was the last one we did in class. So let's recall, this base, we were concentrating on exponential decay. When the base is between 0 and 1, or a fraction less than 1, we're going to see an exponential decay. The shape is reversed than the graphs we looked at again yesterday. So instead of growth goes from the left having a flat line up, but decay starts really high and then it starts, well, decaying as you read it left to right. So here we go. Let's try to use our shortcuts that we were talking about yesterday. Shortcuts. Notice how it's an a times b to the x form. And instead of f of x, I'm just going to use y. But when it's in this form, now since I'm in decay, if I'm in decay, last time we talked about how -10, if I plugged in -10, it's going to be a really, really, really big number. So instead of plugging in -10, let's just plug in +10, 0 and 1. +10 should be the 0.00, it's actually 0.0001. So now, when we plug in a 0, hopefully this is getting better. 2/5 to the 0 powers 1 times 4, we're just left with that leading coefficient. When we take 2/5 to the first power, if you want to do this quickly, you got to remember your fraction rules. The coefficient's going to be over 1, so just a little thought. 4 over 1 times 2/5 is going to become 8/5. A little over 1. Let's graph it. I also realized, wait a second, we have nothing. Wait, yesterday, because we were dealing with growth, the base was bigger than 1, we plugged in 0 and 1. But because we are going into decay and it switches, not only would we have to switch this number, but we should also plug in -1 instead. So let's plug in -1. Review of fraction rules. If you take a fraction and put it to a negative power, it reciprocates the fraction. So now I'm going to have 4 over 1 times 5/2. We've got a cancellation, and I'm left with 10. Let's graph it. So at this moment, sub, if you could just pause so that way they could catch up. We're going to discuss domain and range. Domain, you should all already know, all real numbers. Range, since the leading coefficient is positive and my flat line is approaching 0, range is going to be all the outputs came out to be positive. Asymptote, if I was just describing the asymptote, just like yesterday, asymptote is still relatable to the range. Next example. My bad. Before we go to the next example, we're going to remember just from yesterday how we're going to cut the equation to be this basic form, y equals a times b to the x, and then we're going to look at those translations, how if you cut the function in the exponent, it's going to be opposite of what we're thinking. You're going to move right or left, but it's not going to go the way the sign is. However, the plus k, whatever's in the k position, if you're adding or subtracting, that's going to be vertical, either up or down. So now we're ready for the next example. I'm going to cut the equation. I'm cutting the equation to where it's 5 times 1/8 to the x. I'm going to do a t-chart with that and then translate the points. Because I notice the base is less than 1, it's decay. So I'm going to plug in the points -1, 0, and then +10. Practicing my fraction rules so I can get without a calculator. If you raise 1/8 to the -1 power, it switches, or it reciprocates the fraction. So we've got 8 over 1, my bad. We have a coefficient, 5 over 1, times now the reciprocal of the fraction. We actually get 40. That's going to be off our graph. Let's plug in a 0. When we plug in a 0, we're left with that leading coefficient of 5. And then 10, if we plug in 10, When we plug in 10, we get the slightly above 0, so close and above 0. So what I'm going to do in my graph is I'm going to graph those points, but then they're going to be in purple. These old points are going to be in purple, and then I'm going to graph the new points using the translations. I'm going to graph the new points in red. So old points. Now new points are going to be moving left 1, because it goes opposite of what we're thinking, but this one vertically down 2. So those points are going to go left 1, down 2. Keeping the shape. Notice where the flat line is at. That's going to adjust. It's not going to adjust our domain. Domain stays, all real numbers. But the range now changes. The range is adjusted because of this down 2. So all the coordinates, the outputs, are going to be above -2. And the asymptote is relatable. Y is equal to -2. Next example. My bad, before the next example, live quantity decreasing by a fixed % each year. So we're going to talk about depreciation, like a car or a house. Instead of like the growth one, there was a plus sign here. We're now going to subtract the rate all the time. But A is still your beginning amount, R is still your rate written as a decimal, and T is still your time in years. So in our example, you've got 40,000 homes in your city. Each year, 10% of them are expected to disconnect from septic systems and connect to the sewer system. We're going to write an exponential decay for the number of homes that still use septic systems. Wait a second, we're going to write a model for the number of homes that still use septic systems. We don't have a variable written here, so writing this model may be a little difficult, like where does our variable stay? We've got to figure out, all right, well, where does this 40,000 go? And we know this is our rate. So starting with the equation. So this 40,000 definitely cannot be in the T position because T has to be in years. So 40,000 is going to go in our A spot. 10% is going to go in our rate written as a decimal. So we have the following model, but let's clean this up a little bit. Let's take 1 minus 0.10 or 0.1. So our model becomes, the base now is 0.9 to the T power. Notice how 0.9 is less than 1, so this is why it's exponential decay. We're going to use this model to estimate the number of homes using septic systems after 5 years. So again, I say 5 years, that's going to plug in to the T. We're looking at about 23,620 homes are going to be using the septic system. With that, that's the end of this lesson. You are ready for homework. Notice how I'm doing evens. If you have questions on anything, I expect you to chat with me on Remind. Also, you can do that as you're doing your homework today. Chat with me on Remind. That is okay, sub. So if they're on their phones, they can be on their phones. All right. If you need a picture of the book, it is above, it's by the 7th hour folder at the front of the room where it says absent, I guess more by the toilet paper. All right, so message me if you need help. Thanks, bye.